Welcome to the Businesstalk podcast. I'm your host Deepak from India. We are pleased to welcome Dr. Remy Levin, Assistant Professor of Economics at the University of Connecticut, as our distinguished guest on today's podcast. Dr. Levin is a behavioral economist whose research explores the co-evolution of risk and utility, both theoretically and empirically. His work bridges several areas of economics related to decision making under uncertainty, including the economics of insurance, financial economics, economic history, macroeconomics, agriculture and development economics, and economics of climate change. At University of Connecticut, he teaches behavioral economics and microeconomic theory, co-organizes the microeconomic seminar, and is a faculty affiliate at the Yukon Cognitive Science program. Dr. Levin earned his PhD in economics from the University of California, San Diego, specializing in behavioral economics and decision theory, with a focus on risk and uncertainty. His dissertation, Adaptive Risk-Taking, investigated how individual risk preferences evolve through lifetime experiences of aggregate shocks such as macroeconomic fluctuations and climate change, utilizing large-scale panel survey data from Indonesia and Mexico. During his doctoral studies, he co-authored a widely cited frontier study on the genetics of risk preferences and contributed research on the role of stay-at-home orders in shaping COVID-19 transmission dynamics. His current projects include developing new methods for measuring risk preferences in a historical context and examining how personal experiences shape learning and labor market behavior. Before pursuing graduate studies, Dr. Levin completed his undergraduate degree in mathematics and economics at Western Washington University, where he is also engaged with political science and philosophy. His early scholarships included research on the relationship between American constitutional law and international law, and an undergraduate thesis on fractal geometry. Prior to his academic career, Dr. Remy spent a decade as a long-distance backpacker and thru hiker, an experience that informed his enduring interest in applied risk-taking. In this episode, Dr. Remy Levin shares key insights from his research, measuring risk in the deep past, economics beyond the data. It's my pleasure to now welcome Dr. Remy Levin to the conversation. Dr. Levin, we are truly honored that you have accepted our invitation and delighted to have you with us today.
Thank you so much, Deepak. It's a pleasure to be here.
Professor, what inspired you to explore the idea of measuring risk preferences in historical context, where traditional data sources are scarce or non-existent?
Yeah, that's a great question. So I think on my end, I really started getting into this from a personal angle, right? So where it starts for me is, my grandparents were in the Holocaust, right? And that's like a significant generational trauma that I saw personally. And when I was growing up, I could see the effects of that trauma having a persistent effect in my own family, right? So, for instance, I grew up in a household that was extremely risk averse, And then when I became an adult, I kind of went in the exact opposite direction. So I spent a lot of time before my graduate studies engaging in what I call a 10-year vocation in applied risk-taking. I was doing a lot of long-distance backpacking and through hiking. And so I have this kind of very personal relationship with the idea of risk and risk-taking, right? And then when I got to graduate school, I became really fascinated by risk preferences and the way we think about risk and risk preferences in economics, And I think to understand why, I think it's really important to understand why risk preferences are so important in our understanding of economics and the way people make decisions in economic settings and in general settings. So the way I think about risk preferences really is that to a large degree, they're the most important psychological or behavioral construct in the social sciences, definitely in economics, and then more broadly in the social sciences, right? And why is that? Well, when you think about the theoretical framework in economics, right, it's based on constrained optimization. So we have some goal which is the utility function for individuals. And then we have constraints, like elements of the environment that shape the limits of what we can do, right? And constrained optimization, I think, is one of the great triumphs of economics, right? It's a big reason why we've been so successful with explaining individual and firm and market behavior over time, right? And a key element of that framework is the utility function, is the goal of the agents. And those utility functions, the goals of agents like firms and individuals, they're different between different people, right? And if you think about how they're different, you can think about the features of the utility function itself. And so when you think about this, right, we can think about like the derivatives of the utility function. The first derivative of the utility function, which determines how much people like having more rather than less. That's not very controversial. So typically we're very comfortable with assuming what we call monotonicity, right? Everyone likes having more rather than less, right? That's pretty universal. But the second derivative, which is really all about people's attitudes towards risk, that's like a free parameter in the model, you know? And to a large degree, people's attitudes about risk have shaped our theory of utility over time. So in fact, all of the utility functions that we use in applications and in models have primarily been shaped by their properties towards risk, right? And so risk preferences, I think, are kind of the central construct for understanding utility and therefore constrained optimization, right? Now, here's the thing, like I've said, this framework of constrained optimization is this great triumph, right? But there's a dirty little secret built into our existing frameworks. And that's the fact that in our current economic theory, we generally assume that people's preferences are fixed and exogenous, which means we think of them as unchanging over time. And we typically don't think about where they come from, you know? And to a large degree, this is a tradition in economics. This goes back to the 70s with Becker and Stigler, these two, Chicago Nobel laureates who made the point that, preferences are not observable, at least at that time, and constraints are. So we should think about dynamics as driven by changes in constraints, right? But the thing about that assumption is it's on its face ridiculous, right? Because if you just think about yourself as an individual, the things that you want now are not the same things that you wanted 20 or 30 or 40 years ago, right? And we have all of these industries in the economy, like marketing and political agents, that whose whole job is to change our preferences, right? And get us to want things. So obviously these things change, but we're assuming in economics that they don't, And that's a barrier to making the field, to my mind, more scientific and stronger in our understanding of people, right? And so I started thinking about this in graduate school, and my work there was kind of launching or starting in the direction of thinking about how to think about these changes in preferences. And originally, when I was working on this, I started working with data in the present day, right? So we have these surveys from a bunch of different settings. They're especially good in the developing world, like in Indonesia and Mexico in particular, where we measure risk preferences for the same people years apart. And my early work was about linking these within person changes in preferences to changes in people's environments, right? And then once you start doing that, and then also through my work on the genetics of risk preferences, you realize that a lot of the story about these changes in preferences is a story of adaptation to the environment, right? And then once you start thinking in the direction of adaptation, that pushes you towards a more evolutionary perspective on changes in preferences, right? And then once you start thinking about evolution, then changes over really long time periods start mattering, right? You want to start and you want to understand how these preferences change over long periods of time. But here's the problem with doing that. We have a fundamental measurement issue. Up to this point, we haven't really had any way of measuring people's risk preferences in the deeper past, you know? And so the inspiration for the work that we're talking about today is really to try and get around that measurement issue by developing methods for measuring these behavioral constructs in the past. It's almost like, like a form of behavioral archaeology, right? Like trying to reconstruct what's happening in people's heads in the deeper past, you know?
Dr. Levin, how do economists go about reconstructing decision making under uncertainty when they lack direct behavioral data from the past?
Yeah, that's a great question. So we're at the infancy of doing this, right? And this paper that we've just come out with as a working paper, the Yeoman's Portfolio, is really, I think, probably the first attempt to do this in a serious way, right? But if you think about how this works, the big thing that you have to think about to begin with, right, is how we actually measure risk preferences in the present day. When we think about that, the key idea is that we do that by looking at these clean or simple choices that involve risk when we give them to individuals, right? So, like for instance, if I'm measuring this in, say, the survey data, or I'm talking to somebody, I would ask them. I would give them a choice, something like, for instance, Deepak, would you like, you have a choice between two things. Would you like $100 for sure? Or I could toss a coin. Heads, you get $50. Tails, you get $200, right? So for instance, if I gave you this choice, what would you take, do you think?
200, obviously.
200, well, but you have a choice between 100 for sure
Yes.
or 50-50, 200 or 50. Do you go
50-50.
for the point? The 50-50? Okay, great. So that's the risk-seeking choice, right? And the sure amount is the risk-averse choice. So if you give people several different choices like this, you can estimate what their preferences are for risk, right? It's kind of the clean way to do this, okay? Now, the thing is, those kinds of measures we only have going back to the 90s. So that's when we start having the survey data. So if you're interested in like measuring the stuff in the past, how do you do it? So here's the basic insight. You think about a risky decision that you can observe in the past and that we understand relatively well in the present day, okay? And so there, the inspiration for the paper is to say, look, let's think about agriculture in particular, decisions in agriculture, right? Why? Well, if you think about people in the last like 10,000, 12,000 years, right? 99.9% of humans in the last 12,000 years, since the Neolithic Revolution, were farmers, right? Everyone was engaging in farming. Farming is extremely risky. You're subject to climate risks, right? You're producing stuff outside. You don't know what you're going to get. So that's a very high stakes, risky decision. And there's potentially data that exists about those kinds of decisions, right? You can observe what people were planting, for instance, at least in principle. You can observe the climate in the past. There's a lot of people working on that. Maybe you can observe prices if you're thinking about commercial agriculture, right? And on top of that, we have a pretty strong understanding of how agricultural decisions are done in the present day. So especially in work in agricultural economics and development economics that kind of studies like small scale agriculture today, we have a pretty good understanding of how people's risk preferences relate to their decisions in agriculture today. So using those insights, using the fact that the data about this exists in the past, and that we understand this kind of risky decision in the present day, you put those two things together and you try and measure these risk preferences off of these risky decisions in agriculture in the past. For instance,
Professor, could you describe some of the key methods or tools you use to infer risk attitude from historical records, artifacts, or economic patterns?
Yeah, definitely. So the big kind of overarching method is what's known as structural models. So what does that mean? So if you think about work in economics, like actual research that people do, right? You can think of it as kind of lying along a spectrum between pure theory, and pure data work, right? So on one end of things, you have theorists that are writing down and studying economic decision making or behavior just theoretically, like purely theoretically, right? And on the other side of things, you have economists that are studying economic decision making and markets purely empirically, right? So they use data, and we have all of these methods, causal identification in economics, for trying to take data and look at like relevant policy decisions, how people change their behavior, and what's the effect of various policies, right? And then in between these two extremes, you have what's essentially a blend of theory and data. This is known as structural work. And so what does that do? You essentially write down a model of how you think the environment works, and then you bring the model to the data, okay? And you try and estimate key parameters within the model using the data that you have, okay? Now, a lot of work in economics is like this. So a lot of macroeconomics does this, right? A lot of it is very structural. A lot of work in behavioral or experimental is like this. You have an underlying model of human behavior, and you're trying to bring it to the data with like experimental data or observational data, right? So the overall method that I employ, or that we employ for doing this, is structural work. Essentially, what we do is we write down a model of the environment, our best idea of how the environment works, and then we try and bring that model to the data. And so what does that look like in this setting? So specifically, in this paper, we focus on one piece of the agricultural production process that we think we understand pretty well, and that's the decision of which crop to plant, okay? So this is something that farmers do all the time, right? They have different seeds and different crops every year or several times a year. They need to make a decision of what to plant. They have a certain amount of land, and they have different options of what to plant. Now, theory work in economics in the present day tells us that you can think about this decision as essentially as a portfolio allocation problem. So just like an investor has like a pool of money, and they need to take some of that money and decide, do they want to put it towards a risky stock or keep it in a savings account or a safe bond, right? You can think about a farmer taking their portfolio of land and allocating some of it towards maybe high risk, high return crops, right? Like maybe cash crops that might sell on the international market, but might be risky or subject to disease, for instance, versus like a safe food crop, for instance, right? So what you do in this specific setting is you write down a model of how that would work in agriculture as a portfolio allocation problem, okay? And so in that model, you think of a farmer who's allocating their portfolio of land, and they're subject to risk in the environment that comes from two main sources. One of them is the climate or the yield risk, right? You plant the plants and will they grow or not? And then the other source of risk is price risk. So then once you grow the plants, how much are you going to be able to sell them for? It's very hard to predict, right? So you write down a model of a farmer who's making decisions like these in the setting of these risks. And then in that model, there's basically three empirical objects. There's the decisions that the farmer is making. There's their beliefs about the returns of different crops as assets. So just like with stocks and bonds, you can think about people's beliefs about the variance and the covariance of the returns of different crops, and also the expected value of those crops. So that's their beliefs about the returns. And then the third object is their risk preference, right? Like how comfortable they are with taking these risks in planting the crops. So once you write this model down, what you can do is you can say, look, if I have data on what people plant, and I have data on what they believe when they're planting this stuff, then I can use the model to back out their risk preference, the risk preference that we see in the model, right? And so when we do this in our paper, what we do is we go back to a setting where we have really good data, because this is like the first paper doing this, and it's like a proof of concept that you can do this, right? So we go back to a setting as far back as we can where we have really good data, which is the late 19th century and early 20th century in the United States, okay? And in that setting, we have data from the agricultural census on what people planted and their different yields. So we can use that for the choices. Now, the beliefs are trickier. The beliefs are something that's happening in people's heads. So how do you get a measure of that? Well, we can't directly observe it, but what we can do is we can say, look, we think that people's beliefs are formed based on what they experience over their lifetime, and we have data on what they experience. So we see yields of different crops. We also see historical climate. We can predict what the yields would be that they saw based on the historical climate. And then we can reconstruct beliefs based on that. And using those empirical measures of beliefs and what we see about people's choices, we can then get an empirical measure of their risk preferences. And so we do that, and we end up getting this measure of risk preferences at the county level in the United States for 4 different waves of the ag census. So we see it in like 1890, and in 1900, and in 1910, and in 1920. And to my knowledge, this is like the first time that we've really been able to like see these things in the past. So that should give you an idea. I think that's that's kind of that's what I would describe as kind of the frontier method of like how you would do this.
Professor, in what ways does combining insights from economic history, behavioral economics, and cognitive science strengthen our understanding of historical risk taking?
Yeah, great question. So none of this work would be possible without pre-existing work in economic history, right? So there's this huge group of economic historians that over time have just been doing this hard-earned spade work of getting us data from the past, right? And collecting all this data on economic behavior. And so, I want to shout out my colleagues in economic history. It's a relatively small field in economics, but I think it's really growing, and it's one of the most exciting fields. And over the last couple of decades, it's really taken this very empirical turn, and we're getting all of this incredible data out of the past, right? So, for instance, the agricultural census was assembled by economic historians just in the last, couple of decades. And without that, it would be impossible to do the work, right? By the way, the other group of people that I want to shout out for this specific work is climate scientists. A lot of their work is under threat right now, but climate science has done this incredible job of estimating the historical climate going back. So, for instance, in this paper, we use this open source data that exists where you can, climate scientists have managed to reconstruct historical climate at the zero point 0.7 by zero point 0.7 degree level, which is just like a couple counties, like in the United States, like at that geographic level, at the 3 hour temporal resolution. So, like every 3 hours, going back to 1806, going back like 100, like 220 years, right? That's wild. That's like crazy, right? So, and that's all this like spade work that's happening in the background with the climate scientists reconstructing historical climate, right? So none of the work would be possible without the amazing work of people in economic history and climate science reconstructing this data from the past, right? As far as behavioral economics, I think what behavioral really brings to the table is a basic set of methods for measuring people's risk preferences, right? So we wouldn't be able to do this unless we had kind of, 40, 50 years of the experimental revolution in economics, right? It's really in the context of behavioral and experimental economics that we've thought very carefully and we've about the foundations, the very foundations of our models, And just kind of to say this too, people think a lot of times about behavioral economics as a field that's dedicated to like overturning traditional economics, right? I don't think about it that way at all. I think the what the field is really doing, hopefully, in the long run, is improving the existing economic framework by thinking about it really, really hard and figuring out ways of measuring the basics of it, the foundation of it, the fundamentals of it, very, very well, right? So I think that's where behavioral comes in. And then cognitive science, and I would say also neuroscience, right? And then biology more broadly. I think these are fields that are in the midst of really revolutionizing behavioral economics, right? So the last couple of years, there's been a lot of talk about the cognitive turn in behavioral econ. There's this great paper on this by Ben Enke at Harvard and co-authors about the way behavioral econ is kind of taking this cognitive turn. And I think what's happening there is we're getting these insights about linking these methods that we've got in behavioral more formally to the underlying biology and like evolutionary framework. And ultimately, that's kind of what underpins this idea of thinking about evolution and thinking about adaptation of preferences. And so I think really that's what those fields are bringing to the table for this work.
Professor, what are some striking examples of how ancient or early modern societies exhibited patterns of risk management that resemble or differ from those of today?
Yeah, that's a great question. So I think the main answer that I would give to this is that one of the things that we're starting to see is that these people that we're observing were very likely a lot more rational in their decision making than we typically give them credit for, right? And so, this is kind of like a general, what I think is a general kind of like narrow-minded perspective in the field or in academia more broadly, right? People tend to think about people in the past and to some degree, and very erroneously, people in like developing countries in the present, right? As irrational or ignorant to like some degree, right? And I think that's totally false. Okay, like I think that in reality, what's going on is people in the deeper past are faced with these very high stakes decisions, that they have to make. If you think about it, like agricultural decisions or production decisions in these settings, that's people's livelihoods, right? Like if you make the wrong choice, as far as like what to plant on a given day, then like within the year, your children are like starving, right? Because you don't have a lot of a social safety net for making these decisions in a wrong way, right? So people are under a lot of pressure to get things right. And I think when people are under pressure to get things right, there's a lot of pressure to be rational and to try and make the right decision in this high stakes environment. And so, our work is still in its infancy, but what we see already is that, for instance, the distribution of risk preferences that we're seeing in the past, just looking at like the distribution, right? Just like the data that we're getting, that distribution looks strikingly similar to the one that we see in the present day. So, for instance, like you go out and like measure risk preferences in the present day, you estimate the parameter. What do you see? You see that a good chunk of people are risk averse. They dislike risk. A smaller percentage are like risk seeking. You always have those folks that are going for the risk in society. And then most of the risk preferences of people, if you estimate this number, lie somewhere between -2 and 2, okay? Where 2 is like a moderate level of risk aversion, and -2 is a moderate level of risk seeking, okay? And of course, there's people in the tails. There's always like extreme people, right? Okay, we measure this in the past. Literally, we see the exact same pattern. So the risk preferences that we see between 2 and -2, right? Most people are risk averse. Some people are risk seeking. There's some extremes, right? I think that's very striking. I think that you could imagine that we would do this, and you just see people being crazy or like being stupid, right? Like they don't know what the hell is going on. That's not what we see. They're a lot more similar to us today than we might think, right? The other thing that we're seeing is that, and I think this is also to be expected, but I think it's some of the first confirmation of this empirically. Selection really matters into environments and therefore into preferences, right? And so, what do I mean by that? Like in the United States, right? Like if you think about like our culture here in the US, right? What is the culture like? We're in general, and this is how I like to think about Americans in our good moments, right? We're very entrepreneurial. We're very, open to innovation, right? Like we go out to the frontier and, we're always trying to innovate and compete and be original and creative, right? And I think to a large degree, that's a selection effect here in the United States. We have a huge privilege here, which is that to a large degree we have, and hopefully in the future we keep attracting the best and the brightest from like all over the world, and the people who want that kind of like innovative entrepreneurial spirit, right? And when we go and that what that translates to is that a lot of times what we see in our economy is a lot of risk taking that you don't see in a lot of other settings, right? So like American companies are like open to like innovation, and American workers are open to kind of taking these big risks that can be hard to do. And when we go to the past, we see that as well. So, for instance, one of the patterns that we see in the data, just in the early stages of this paper, is we have these measures again from economic historians of exposure to the American frontier in the 18th and 19th centuries. So Sam Botsey and Martin Finsbein have this great paper on the effects of exposure to the frontier on individualism in the United States, right? And so, they make the data open, and we can get their data on exposure to the frontier. One of the things we see in our paper is that individuals in counties with more exposure to the American frontier in 1890 were more risk seeking, right? So there's these selection effects that we can see going all the way back that echo what we see today in the history of the country and people's behavior, you know?
Professor, how do concepts like utility or expected value change when applied to contexts far removed from modern markets, such as pre-industrial societies?
Yeah, another great question, Deepak. Okay, so there's a couple levels of like answering this, right? So first of all, at a very basic level, we don't know, right? And we have to be, I think, kind of humble and modest in the assumptions that we make about these societies, right? Because like at the end of the day, we can't really. It's very difficult to like see how people actually think, right? And we have this whole amazing field of history where the historians spend a lot of time kind of like trying to figure this out, right? So at a very basic level, we don't entirely know, and we're making assumptions. Okay, but here's the thing: we can make some kind of informed assumptions, and the way that I would think about this is, in a way, this is very similar to physics. Okay, so in physics, we have all of these like homogeneity conditions, right? We tend to think about physical laws as being homogeneous in space. So like the way physics works here is the way physics works many light years away, and we think of them as homogeneous in time, for instance, right? So like the way physics works now is the same way that physics worked previously. And those assumptions have implications, right? They have implications for things like, the conservation of energy and the conservation of momentum and the like, right? But at some kind of like very basic philosophical level, those are assumptions about homogeneity, right? Though they have implications. There's a sense in which when we do this kind of work, we need to make these kind of homogeneity assumptions as well, right? So to some degree, the assumption is that people in the past were essentially like us in the sense that they were facing risks like us and they were thinking about risks in similar ways to us, okay? Now, is that a reasonable assumption? Well, here's the thing. Of course, societies were very different, but one of the things that we know about the world in general is that in general, we're all kind of exposed to these evolutionary pressures, right? Like in the environment. So, competition and kind of like survival of those who are successful and selection effects, right? And this idea that you have constraints and that you're trying to do the best that you can subject to constraints. That's never changed. That's just a feature of like the natural environment, right? And so I think it's very reasonable to think about people in the past as subject to those pressures, and honestly, like even more potentially subject to those pressures than we are today, right? Because things were pretty rough in the past, right? There's now you go on like social media and people are like pining for being a hunter gatherer, right? But like let me tell you, it wasn't that great, right? Like agriculture is a very tough like job to do, like so things were very tough in the past, right? And so I think it's reasonable to think about people's behavior as at a very basic level being driven by these selective pressures in the past, just like they are today, right? And so when we make these assumptions, we try and make these kind of informed homogeneity assumptions, and that's kind of the main one in this context.
Professor, what challenges arise in separating cultural beliefs or institutional constraint from individual risk preferences in historical analysis?
Yeah. I think the challenges are significant, right? So, of course, on the one hand, I'm emphasizing, the past is like us, right? We're like the past. It's all kind of universal. But I mean, the flip side of this is the past is also very weird, right? And like people were strange. we're strange right now in like our very specific ways, right? But you know, if you look at like Joe Henrich's work on like weird societies now, right? They make the point that a lot of our understanding of the present is shaped by, you know, kind of like people in developed countries that have like a very specific background, and we need to be very careful about projecting those results to like societies today. And the same thing is true about the past, right? You know, like people were, I think, equally strange, but strange in their own ways. You know, like with their cultures. So it's a big challenge. It's a big challenge to think about this. So I think the right answer, or the way that I tend to think about this, is that we need to proceed step by step, right? We need to proceed with caution. So I think what we start with is we start with settings that we do understand relatively well, right? So, like for instance, this paper, the Yeoman's Portfolio, that's focused on small scale agriculture, right? Small scale commercial agriculture. Okay. And so, you know, the specific setting is like, you know, thinking of farmers that are growing crops that they're selling, like on the market. And of course, they're small. It's before kind of the consolidation of agriculture in the 20th century to like these big farms, right? Now, that's something that we understand relatively well, and we have a good amount of data for, because we still have a lot of small scale agriculture in the present day, right? And this is another place where I have to shout out development economics and our colleagues in development, right? Because a lot of the work on understanding small scale commercial agriculture comes from there, right? And I should say, especially from seminal papers in India in particular, right? Like a lot of the work has happened there, right? But we understand the setting relatively well. So I think the first step that we do is we go back to the setting that we understand relatively well. Once we do that, we kind of try and extend this step by step to settings that are increasingly strange and foreign, right? And so I think the next step is going to be to think about how we measure these risk preferences in settings where you have subsistence agriculture rather than small scale commercial, right? Because that's what we're going to need to be able to go farther back. And of course, you know, there's other ways of I'm not working just in agriculture. I'm also working on estimating these things using other kinds of records like insurance records or writings, right? That things that are preserved in the historical record, right? But I would say that's really kind of the key is kind of, you know, being systematic, being scientific, going step by step, right? But the thing is, in doing that, I think that what we're doing right now has a lot of promise, right? Because again, you kind of zoom out to like agriculture. At least we have hope of like estimating these things. The decisions exist in the historical record for people in the deep past. So if we can figure out how to do this, going back 120 years, right? The dream is that we can use that same kind of basic method, and I think we will be able to, going back 1,000 or going back 10,000 years, right? And as we get more data and a deeper understanding of the past, I think these methods are going to become increasingly powerful, you know?
Professor, how might measuring risk in the deep past help us make better sense of contemporary economic behaviors under uncertainty, such as climate or financial risk?
Yeah, great question. So there's I think the way I would think about this question is at two levels, right? So first of all, I think that you know, the past and the present are linked, but they're linked in both directions, right? So in the same way that we can use insights in the present day to understand the past, we can use insights in the past to understand the present day, right? So if people in the past were like us to like some degree, the challenges that they were facing in the past are kind of similar to the challenges that we're facing today. And by understanding how they made decisions in those settings, we can understand better, perhaps, I hope, how to overcome the challenges that we're facing today, right? So, for instance, some of my other work, this is not out yet, but it's in process. Some of my other work is looking at risk taking in the context of the historic whaling industry, right? And I don't know how much you know about whaling, but this used to be a really big thing, right? So we don't hunt whales today for the most part, which is great, right? Because they're amazing creatures. But in the late 18th and early 19th centuries, whaling was a huge industry. It was like the fifth largest industry in the American economy at the time. And why is that? Because whale oil was essentially the petroleum before petroleum existed, right? It was the previous source of energy, And then during the course of the 19th century and the 20th century, we had an energy transition. We essentially went from using whale oil to using petroleum, right? From pre-fossil fuels to fossil fuels, right? And so, for instance, if we can understand risk-taking over that previous energy transition, maybe we can understand better the way to manage risk in the current energy transition that we're going through, right? From oil and fossil fuels to renewables and more sustainable sources of energy, right? So I think that's a striking example. At a deeper level, I think the big prize here is in understanding the evolution of preferences and the evolution of utility, right? And that's a big prize, okay? Because the ultimate dream is to kind of unify these concepts, unify the concepts of fitness and utility, unify evolutionary theory with economic theory, because to my mind, that's at a deep level what's going to be necessary to understand really the way people make decisions in the present day. And so if we can do that, I think we'll be able to understand dynamics of these decision making and the way people make decisions in the present day better,
Dr. Levin, have you encountered any surprising findings that challenge the way modern economists think about rationality or adaptation over time?
Yeah. So, the work is still in its infancy, right? We're still getting some of the initial results. But one of the things that I would say that's kind of the big challenge to the existing framework is the fact that you see these adaptive dynamics in risk preferences in the past and also in the present day, right? So, I mentioned this kind of tradition or orthodoxy in economics of thinking about preferences as not changing, right? And what I'm working on to a large degree is kind of building up evidence that increasingly will make that assumption untenable, right? Because essentially, this assumption, I think, is an orthodoxy, and orthodoxies, they don't have a place in science, right? Orthodoxies are a function of religion. If we're going to do science, I think we should not be thinking about things in terms of tradition or orthodoxy. We should be open to what the data says, right? So I think the number one kind of challenging result is these adaptive dynamics that we see. They exist not just in the present day, they exist in the past. Right? And so when we see these risk preferences changing over time, we can attribute these changes to this adaptation to the environment that we're seeing in the data, right? And so, yeah, I would say that's kind of the big challenging result. But we're still working on stuff, and I think there's going to be a lot more stuff that hopefully will be coming out of this,
Professor, I would like to conclude this episode with one last question. Looking ahead, how could the study of historical preferences inform broader conversations about human behavior, resilience, and learning across generations?
Yeah, good question. So again, I've said this a few times, but I want to I bring this back to the context of thinking about evolutionary theory, right? So the big prize is unifying economic theory with evolutionary theory. The way to do that is to understand long run dynamics of utility, so of the objective in the constrained optimization problem, and of constraints of what's happening in the environment in the constrained optimization problem, right? Now, the thing about evolutionary theory and economic theory or decision theory is they have very strong parallels. Constrained optimization is the name of the game, right? Both in economics and in evolution, and also to a large degree in like physics, right? When we think about like the way the world really works, right? So there's reasons to think that these things are related to each other, but in order to really tie them together, we need empirical work on these kind of long run dynamics. And we also need theoretical work, which is also something that I'm working on understanding how these dynamics of utility work and like how they shape people's decision making in the present day, right? So I would say the kind of big thing that we can get out of this is hopefully this bigger understanding of today in terms of the long run evolution of our behavior and preferences in the past.
Thank you, Dr. Levin, for sharing such fascinating insights into how economics, history, and human behavior intertwine across time. It's been a pleasure exploring how we can understand risk beyond the limit of data. And to our listeners, thank you for joining us. Thank you, Dr. Remy Levin, once again for joining with us today.
Yeah, thank you so much, Deepak. This was a pleasure. I really appreciate being able to talk to you about this.
Thank you.